Hello, and welcome to Game Theory. I'm Professor Naomi Utgoff of the United States Naval Academy. In this video, we'll continue our discussion of subgame perfection as a refinement to Nash equilibrium. The goal of this video is to give a more elaborate discussion of the distinction between subgame perfect Nash equilibrium and its non-subgame perfect counterpart. We'll pick up from the previous video with an example of backwards induction, this time in dynamic battle of the sexes. Here's the tree of dynamic battle of the sexes. Each of the woman's moves is a last move. It doesn't matter which of her nodes we use to start backwards induction. Backwards induction will produce the same result either way. Let's start at the node in blue, subsequent to the man's selection of ballet. 2 is greater than 0, so the woman selects bold ballet, shown in blue. Delete bold boxing from the tree. Now this tree, in black, remains. The last move is the node in blue, the woman's move subsequent to the man's selection of boxing. 1 is greater than 0, so the woman selects italic boxing, shown in blue. Delete italic ballet from the tree. Now this tree, in black, remains. In this tree, the last move is the man's move, indicated by the blue node. 2 is greater than 1, so the man selects boxing, shown in blue. Delete the man's action, ballet, from the tree. Now this tree, in black, remains. We've reached the top of the tree, so backwards induction is complete. The unique subgame perfect Nash equilibrium is that the man plays boxing, while the woman plays boxing conditional on the man going boxing, and ballet conditional on the man going to the ballet. In this game, the first mover has the advantage of knowing that a rational second player will follow the first mover's lead. Some games feature first mover advantage, but in others it may be advantageous to go second. Dynamic rock, paper, scissors features second mover advantage, since going second guarantees a win. In order to see how subgame perfection refines Nash equilibrium, we're going to find all of the Nash equilibria that are not subgame perfect. We'll do this by writing down the matrix form of dynamic battle of the sexes and finding its Nash equilibria by underlining best responses. Recall from video 26 the strategy spaces of dynamic battle of the sexes. We'll use the strategy spaces to construct strategy profiles. We will then use the induced path of play from each strategy profile to fill out the matrix at right, with the man as row player and the woman as column player. In the top row, the man plays boxing, so the italicized action in the woman's strategy is the one on the path of play, and the bold action is not. The man goes boxing, the woman follows him to boxing, and payoffs are 2 and 1 respectively. The woman's strategy has changed from the previous slide, but the induced path of play has not. The man goes boxing, the woman follows him to boxing, and payoffs are 2 and 1 respectively. Now the woman goes to ballet conditional on the man going boxing, so payoffs are 0 each. In this strategy, the woman still goes to ballet conditional on the man going boxing, so the induced path of play does not change and payoffs are still 0 each. In the bottom row, the man plays ballet, so the bold action in the woman's strategy is the one on the path of play, and the italicized action is not. The man goes to the ballet, the woman goes boxing, and payoffs are 0 each. The man goes to the ballet, the woman goes to the ballet, and payoffs are 1 and 2 respectively. The man goes to the ballet, the woman goes boxing, and payoffs are 0 each. Finally, the man goes to the ballet, the woman goes to the ballet, and payoffs are 1 and 2 respectively. We're done writing down the matrix form of this game. The tree and matrix are side by side. The matrix somewhat obscures the timing of the game. It's the reason that for the most part we use trees for dynamic games rather than matrices. However, we can and will treat the matrix like any old matrix from the first third of our course for the purposes of finding Nash equilibria. Backwards induction finds only subgame perfect Nash equilibria. However, we have a number of methods for finding plain, old, regular, not necessarily subgame perfect Nash equilibria in matrices. In this matrix, we'll underline best responses and find all of the Nash equilibria of dynamic battle of the sexes. Here, we've underlined the man's best responses to each of the woman's strategies. Note that in the column in which the woman plays italic ballet, bold boxing, both of the man's payoffs are underlined. Both payoffs are best, so both are underlined. Here are the woman's best responses underlined. Again, in the case of multiple payoffs tied for best, we underline all of the tied for best payoffs. Now we see that there are 3 pure strategy Nash equilibria. We'll look at each of these individually over the next 3 slides. Here is the subgame perfect Nash equilibrium we found at the beginning of this video using backwards induction. It should not surprise us to see it again via underlining, since a subgame perfect Nash equilibrium is a Nash equilibrium. The woman's play is rational in both of the non-trivial subgames, including selecting ballet off the path of play. Here is one of the 2 Nash equilibria that is not subgame perfect. It should not surprise us that it did not show up via backwards induction, because backwards induction finds subgame perfect Nash equilibria, not every Nash equilibrium. The woman's choice of bold boxing off the path of play is not rational. If the man had instead played ballet, her strategy would result in 0 instead of 1. Her mistake occurs off the path of play, so this strategy pair is still a Nash equilibrium. And here's the other Nash equilibrium that is not subgame perfect. We can interpret this strategy pair as the woman's attempt to force the man to the ballet by insisting that she will go to the ballet no matter what. However, her threat is not credible, since it is not individually rational for her to follow through and go to the ballet should he in fact select boxing. Thanks so much for watching this video about subgame perfection as a refinement of Nash equilibrium. In the next video, we'll use the tools we've developed to study Stackelberg duopoly.